For 3.5, solving equations and inequalities with absolute values. All right, with W with a slash. The first part of the definition for equations with absolute value is that A must be greater than 0 for any algebraic expression. That's how it writes it in the book. And it calls those algebraic expressions like capital X. This could represent, like if I had x squared plus 5x plus 100 plus anything in there. That's all that big X really means in there. And it means that I have two equations, so one of them equals A, and the absolute value of this thing, whatever expression it was that you had, is equal to negative A. Okay, that's why this has to be greater than 0. So remember that just means that it has to be positive. Sometimes it's weird just to see all these different greater than or less than and just forget it. That just means it's positive. You have that it's equal to A and negative A. So that just means anytime we're talking about the absolute value, which is represented by these bars, that it's the distance from 0. So how far is negative 8 from 0, basically, is what the absolute value of negative 8 means. It's just 8. If I were to look at it on a number line, I'd have 0, 1, 2, 3, 4, 5, 6, 7, 8, and it would be 8 units away. Okay, the same thing, the absolute value of 8 is still positive 8, 7, 1, 2, 3, 4, 5, 6, 7, 8, and that would still be 8 units away. Okay, so sometimes you're going to end up with, so this is a really simple equation, and it's x equals 5, and you have to figure out what x equals. So I break it down into two separate things. So I actually need to go back because if I have this equation, I need to break it down into two equations, and I'm sorry, trying to make it confusing. So if I have this equation, I need to go into these two equations. So now an example of what that'll look like is if I have x equals 5, I have to break that down into those two equations, and I have x equals 5, and this is where I lose the bars, and x equals negative 5. So that one's really simple. It's just what's 5 units away from the origin. Okay, so another example is with a few more things inside the bars and outside the bars. Okay, so I have this guy. So everything that I have to do, I have to solve for, let me even make this a little bit harder than the example. But if I have a 5 in front of my absolute value bars, I need to get this solved for just like I would solve for x. So I need to add 1 to both sides. And then I have 5, absolute value bar x minus 3 equals 5. And then I need to divide both sides by 5. So I have to get this absolute value bar stuff by itself. When I divide by 5, I get the absolute value of x minus 3 equals 5. And then this is where I break it down into two equations. I get it up here. I have x minus 3 equals 5, and x minus 3 equals negative 5. So the only thing you have to make sure of with our old definitions back here that it went into these two equations is that the a right here, this number, is positive. So we have to check right here, is 5 positive? Yes, it is. Or is 1 positive? Because I can't divide right now, and you guys are probably thinking I'm crazy. So I have 1 and negative 1. So is this 1 right here positive? Okay, it is. So I add 3, and I get x equals 4. I add 3, and I get x equals positive 2. Now I have to go back and plug it back in to make sure that I'm not finding more in this equation. I don't need that one. But I need to go back and plug those in. most of the time you get that both of them do work out, or you should, but sometimes you don't because some things get weird. So 5 minus 3 minus 1 equals 4. So order of operations, we treat absolute value bars like parentheses. So I have 5 times the absolute value of 1 minus 1. I can't write anything down, but you guys are probably going crazy. But 5 times 1, since the absolute value of 1 is just 1, minus 1 is 4. And that's good. Now I go back and I try it with 2. And I have 2 minus 3 minus 1 equals 4. And just order of operations. And I have 5 times the absolute value of negative 1 minus 1 equals 4. Absolute value of negative 1 is still positive 1. So 5 times 1 minus 1 equals 4. And that works as well. Okay, so that's how you go back and check your answers. We can also talk about what happens graphically on these absolute value things. So we just have to remember how to graph. If you don't know how to graph these, remember that you can always plug in numbers. I'm going to go back to the example that I have in the book. So basically, I'm going to graph this side and this side. So what this is going to do is remember that your absolute value graph is like a V-shaped thing that would normally be starting at 0, 0 if I have my origin on here. Okay. Anything in parentheses, just like all the other graph shifting that we've done, this is going to move it to the right 3 in here. And this is going to move it down 1. Okay. And then we're also going to graph the line y equals 4. Okay, so we have y equals this thing and y equals 4 that we can kind of compare to each other. So instead of my point on my absolute value graph being at 0, 0, it's going to be over at 3, negative 1. So I'm just going to kind of draw a graph on here. And the graph's not quite going to be square, but it'll be. So I have right 3, down 1. And whatever number you have out here is what your slope is. So it's kind of weird that our slope is really not in here, or sometimes it could be, I guess, but if it's out here or out here, make sure that you're not determining that to figure out those points. So right here, my slope is 1, 1. And on this side, I get the V shape, so it's going to be negative 1 on this side. And then here's my bad drawing skills. And then I'm going to do the line y equals 4. So I get 1, 2, 3, 4. And this is the line y equals 4. Whereas a V-shaped thing here is the other part of my graph. And if my drawing skills have been better, I could see that it doesn't really cross there, but it crosses right there and there, which is negative 2 at 1, 2, 3, 4. Everything that's crossing, notice that that's right at 4. And this one right here is over 2, 4, 5, 6, 7, 8 at 8, 4. Okay, so those would be what our solutions would be. And this one would be x equals negative 2 and x equals 8 for this graph. So what that would look like on the one that we already did with the 5x, let's go ahead and graph that guy as well. So I'm going to go ahead and go over here and write down, I have 5 times the absolute value of x minus 3 minus 1 equals 4. Alright, so the equation of this graph is going to do pretty close to the same thing, just because it has pretty much all the same numbers. But just ask myself if this guy is a plus or minus. If it's minus, it's to the right. If it's plus, it's that far to the left. And up here, if it's negative, it's down. And if it's positive, it's up. So that's kind of opposite from the other one. So, and then this is basically our slope. So if you had another number in here, you like we're basically having we have 1x, so it's 5 times 1 is our slope. So I go right 3, down 1 still, and then my slope is then 5 over 1. So I go up 1, 2, 3, 4, 5, right 1. I have the same thing on both sides. And I'll try to just actually draw a pretty graph with my line here. Okay, so I have that, and then I graph the line y equals 4 as well. So 1, 2, 3, 4. So this one actually works out really nice too. Okay, so this one crosses at 2, 4, at 4, 4, and at 2, 4. Okay, so you should have x equals 2 and x equals 4, and we should have already got that. Not on that one, but on this one. So that was what we got there. And we've already basically checked your answers, but you guys could totally use that to find your answers as well. And then I used to have like a calculator on here so you could look at my buttons. But in order to graph it in your y equals, you push your y equals button. So I graphed this one, and then I typed in 5. Then I have to hit the math button and go over to num, which is just like used for numbers and stuff like that, different in. And then you go, it's already on ABS. You pick ABS, which is looks like that. And then in your y equals menu that you're already in, after you hit enter on this, so hit enter, you're going to have 5 ABS parentheses, then you can type in x minus 3, and another parentheses minus 1, and then you also type in y equals 4 in your second thing. Okay, if you didn't have a number over here, you're just looking at where it crosses on 0 axis as well. Okay, so the other way we could have graphed this is we could have added 4, and that would have been, I'm just going to rewrite on the equation over here, and I have 5 absolute value bar x minus 3 minus not 1 anymore. How about minus or plus 3 equals 4? Or how about minus 4? That would make more sense, huh? No longer 4 either. So minus 5 equals 0. So then what this new graph is going to look like. So I go right 3, so 1, 2, 3, down 5, 1, 2, 3, 4, 5. Then my slope is 5 again, so we're going to 5, 0. And I like just always doing everything equal to 0. Because once it's equal to 0, then I don't have to go in and graph this second one. I have to graph this line right here. And I'm looking at where it crosses this guy. So it's still crossed it at 2 and 4. So that point, so 2 and 4. And then we actually have some inequalities as well. So what those are going to look like is, if I just have some weird expression, whatever I could possibly you could put into that, is A. We rewrite this as something without the absolute value bars, and we have negative A is less than whatever we had, whether this was the x squared, blah, 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 anything we have in there. It's just what we're going to solve for. Okay. That's what this is going to look like with this side. And remember, that would be the same with the equal signs as well. Okay, that's just going to change how we're going to write our interval notation for our answer. just compared to parentheses or brackets. If I have greater than A, that is going to get to change to whatever my expression was is less than negative A, or X is greater than A. And that's the same if I have the equal signs underneath everybody as well. And just because it means or doesn't mean that you get it right. Just one of them, you still have to write both of them. Okay, so what that really means is if I just have some really simple thing, if I have less than or equal to 3, I just decide which way is my thing pointing, and I change that to negative 3 is less than or equal to X, which is less than or equal to 3. Okay, so I have the positive and the negative value. We're also going to have things that you'll actually have to solve for. So I'm going to have the absolute value of 2x plus 3 is greater than 4. Oh, let me step back a little bit and write what this would look like for your notations. So you don't have to draw the number line, since I can't either. So from negative 3 to 3, I have equal signs, so I do it for solid dots, and it's X is greater than negative 3 and less than 3, so it's between these things. So I have square brackets for the equal sign. I have negative 3 to 2 is what your answer will actually look like. Okay, so if you want to write it in both, that's fine, but I need another notation as well. And what this guy's going to look like is I have to write it in 2 statements, the or ones. So I'm going to have 2x plus 3 is less than negative 4. And then I also have, we write the or 2x plus 3 is greater than positive 4. Okay, so if you notice, this one is really the same as our original one. Then I have to flip this side and make it negative. So really the only thing we did with this guy is drop the absolute value box. And then I have to subtract 3 if I can know what I'm doing. And I get 2x is less than negative 7. Or I'm just going through each one at the same time. I'm minusing 3 here as well. I get 1, divided by 2, divided by 2. And I get x is less than negative 7 halves, or x is greater than 1 half. Okay, so less than 7 halves, it's a parenthesis, so it looks like negative infinity to negative 7 halves. Union, that's what we use for those guys. X, whoops, no, x is in the notation, 1 half to positive infinity. To make sure that these guys are in order. So if you kind of automatically set it up that this one goes on your right hand side, they should pretty much already come out in order. No guarantee from there, so but hopefully it'll try to keep stuff in track. Okay, we also have ones. I'm trying to flip flopping all the examples in the book, so not that they won't still get examples. I'm just trying to change them all. Okay, so if I do this guy, I have to look back which way is my arrow pointing. It's pointing toward that guy, so I get to make the between statements. So I make negative 1 is less than or equal to 5 minus 2x is less than or equal to 1. Okay, anytime I have these guys, I have to subtract 5. I don't have just 2 sides anymore, I have 3 sides. Negative 6 is less than or equal to negative 2x. It's less than or equal to negative 4. And then we divide by negative 2. Okay, so what this looks like is 3. Remember that I have to flip these signs whenever I divide by a negative number, which is this. Okay, what this really means is I have to almost break it down to make my 2 or statements. I have 3 is greater than or equal to x, and x is greater than or equal to 2. I don't really like my x on my right-hand side because I think it makes it hard to read. So I just flip-flop where things live, but remember that it has to stay pointing towards whatever it was pointing before. So I have x is less than or equal to 3, and x is greater than or equal to 2. So I write my 2 and my 3 on the number line. I have dots. So it has to be greater than 2 and less than 3. So this is also one that ends up being between. But if you notice that we kind of have these numbers flip-flop, so it just makes it really have to make sure that everything in order and things stay pointing in the right places. So I get 2 solid bracket, 3 solid bracket. So this homework is on page 283, and you can do numbers 3 through 73 by 3s.